in the majority of building stock here in the residential space, nothing is really engineered for airflows at all. From a ducted heating perspective, there's no consideration for return air paths, for exhaust. There's very little consideration for supply air paths. And we just thought there was a bit of a hole in the market of, not many options to put in door vent, which, is less likely to impact the overall air tightness of the building as well when it's stuck in a door.
Hey there, Sam here with the Flow Lab. Before we begin, I want to tell you about a free ebook that we have called What If Houses Came with Manuals? It's a practical resource that shows you how to think about the whole house as a system and not just treating the symptoms. You'll learn about blower door testing, pressure diagnostics, and HVAC analysis. We're sure that this guide will level up your testing game. The link is in the description below.
Welcome to the Flow Lab, the podcast where we dive deep into the science of building performance and HVAC innovations. Today we bring you another insightful episode aimed to enhance your knowledge and expertise in the field. Joining us are your co-hosts, Ben Walker, co-CEO of Retrotec, and Sam Myers, a renowned building science specialist and Retrotec trainer. Together, they bring a wealth of experience and knowledge to ensure our discussions are both informative and engaging. So, sit back, relax, and get ready to enter the Flow Lab, where we'll explore the world of building performance. Let's get started.
Yeah, well, thanks for joining anyway. It's early morning for you guys, huh?
Yeah.
It's probably is this normal time you guys get up? 3:30 in the morning?
Definitely not.
Well, we appreciate the effort.
We work to this time, but we don't get up at this time. That's for sure.
Yeah. Maybe your computer just hasn't woken up yet. Maybe
right.
So, how have you guys been going? Like with the new 7000 series fan, this is a massive product for you guys that you guys just released.
It is, yeah, definitely. No, we're super excited about it. We've been working on it for a really long time. Yeah, it's been hard to kind of not talk about it for, across that product development cycle and everything. But yeah, it's been well received out there and stuff. We're just kind of slowly getting them out into the market and stuff, and assuring ourselves that we won't run into major issues and stuff after a kind of more production run and stuff. So yeah,
and we still haven't made the full-blown announcement of it yet either. I've got a few videos and I'm finishing up now to get out on social media, and I just put one that just kind of gives a detailed rundown of it on YouTube. Just made that one public yesterday, so we're kind of gradually getting it out there.
Okay. And the 500 series, that's sort of in the same boat.
Yeah, that 500 series is more of a specialized commercial duct tester that kind of Colin was working on his way towards retirement stuff. So kind of once he retired, then I already had kind of a full plate, so I haven't really worked on it too much. But we still produce that unit. We still have parts to make them and everything, so motors and stuff.
Yep.
What are you guys using it in Australia for? The Model 500. You guys have one, right?
The Model 500 is very interesting because down here our building regulation require ductwork system larger than 3,000 liters per second to be tested. And a lot of the time, unlike in the past, we only test smaller sample sections of ducts. Now we got called in to test a much bigger section, and we need higher flow duct tester to conduct the test. Otherwise, we need the MEC contractor to subdivide it into a lot more section at the time. Cost balance make it much more preferable to use a high capacity fan.
What static pressure do you guys measure that duct work at?
Well, it depends on different duct section. And as you know, if it is the branch on the floor, it can be ranged from 150 PA up to say 500 PA. But in other like riser or inside the plant one portion of ducts, sometimes we need to do it at up to 1.5 kPa. But recently we got called in a few times to do metro tunnel, cross river tunnel, those kind of smoke ventilation precast concrete ducts. Those they are looking at 2.5 to 3.5 kPa kind of duct pressure. And they are so huge. We will be doing a job next week. They're testing only one portion of the duct, but we need to bring all 5 of our high pressure duct tester, 2 450 and 3 550.
Oh, wow.
Just test one portion of the duct.
Oh, wow.
That's huge. And you guys just daisy chain those fans together, run it in Fantastic, just like a large building test, but with a large duct instead?
Yep.
Yeah, that sounds like a fun project.
We always got a lot of unusual projects coming to us.
I think that the project that you're talking about that you have coming up next week, where you have multiple duct testers do one large piece of duct, I think that's a good example of a lot of the content that I see you guys post on LinkedIn. I feel like you guys are just doing. I kind of describe you guys to other customers as like Retrotec super users. Like if anybody's done like a weird off the wall test, it's you guys. You guys do everything. You just use large building, commercial duct, residential. So for those of that maybe here in the States who've never heard of efficiency matrix, like how did your company start, and like what's the overall mission there?
My goodness. So we started back in, I think, 2009.
Yeah.
And we started predominantly selling products. Actually, we started with a downlight cover product, because recessed lighting is very popular down here, and it's a common issue from a fire rating perspective, but also an airtightness and insulation consistency perspective, to sort of have a solution for those issues. And a lot of our ceilings are very low, and just recessed lighting just seems to be the lighting of choice down here. It's slowly changing though, especially from an energy efficiency perspective. But that's what we started on, and I started doing airtightness testing in a large way, predominantly with underfloor plenums. And from there, we grew substantially.
Yep.
After that, when Joseph left another company that was starting with airtightness testing called ABT, and he joined the company here, and then we grew substantially sort of after that, through that, with just doing whole building testing. And just trying to focus on being the largest capable airtightness tester in Australia, at least.
Yeah, that's awesome.
One thing that is quite different, I think, comparing Australia to US or UK, airtightness tests down under here start with large commercial building. Because our building code doesn't have any requirement on airtightness. So domestic housing market is virtually non-existent, apart from a very small contingency of passive house that they require airtightness testing. But down here, we have a scheme called Green Star, which is the equivalent of LEED in the US. Yep. And they put in airtightness as part of their rating system. And there's a big boost in Australia for airtightness industry.
And is this for residential?
No, that one is predominantly commercial.
Oh, commercial. Okay. And does Australia's government provide any incentive for building to that standard, or is it completely voluntary?
Well, that's completely voluntary, but thankfully the Green Building Council Australia, they've done an excellent job promoting their scheme, and most of the major developers and builders are happy to take on their system. And also the government played their part not by nominating the scheme, but they would give a lot of preferential selection when they need to lease a office building. For example, they would only pick building that has a Green Star rating.
That's good. I guess that's a step forward, if anything. Yeah, from some of the photos and videos that I've seen you guys post, it looks like let's talk about residential for a minute, because I have seen you guys, test some residential buildings, and I feel like the construction types over there in Australia are kind of similar to what we do here in the States, as far as like where a lot of the fail points are, where the leakage is. So if you don't have codes that are requiring airtightness for residential, what's usually a reason for you to come in and test? Is it a comfort complaint or high energy bill or something like that? Or is it all existing, or do you ever test any new construction there?
Well, I think comfort complaint is the main reason for existing building, or sometimes when the home got mold issue, they would try to find out, because we offer to do both air leakage testing as well as thermal imaging. So they come to us, we go in, we check and test and find not enough ventilation and poor insulation consistency. Sometimes we can easily find some big patch of insulation missing in the wall and ceiling.
I think one of the key things with Australia and our building stock here is that a lot of the homes have very similar issues. And with regards to our YouTube channel and the videos that we produce, I mean, obviously YouTube is more angled towards the masses and people sitting in their lounge room, especially these days. YouTube is getting really popular in that part of the house. And yeah, I guess we just focus on showing people with blower door testing where their homes could be problematic, and then just, I guess, showing them some solutions on what they can do to sort of get a better outcome for comfort and health in their homes from a DIY perspective. Because a lot of these fixing up these issues in these homes is actually, a lot of trades don't know about it, don't want to know about it, too difficult, too hard. And it's more of something that someone would want to really do themselves because of the effort that's required.
Sure.
And the fiddliness of it potentially in some cases.
And the other interesting observation that we find is we cannot just find installation method that is applied in the US or Europe directly bring across here. One of the main problem for us installing air barrier here is we use brick veneer, which is common between the three places, but the way how we build the brick veneer is slightly different. Under our building code, we don't need to have sheathing, and we don't need to have continuous external insulation like the foam board, which is very popular in Europe.
Yeah, so I'm guessing if you're not using sheathing for wood frame structures, are you just using like a cross brace inside of the wall?
Correct.
And that's your racking strength? Okay. Wow. That's really interesting. Yeah. Because you really can't get an air barrier that way if you don't have some kind of substrate.
Yeah.
It's very difficult.
Yeah. Interesting.
We are both blasted and cursed by the mild weather we experience here. Apart from the portion of Queensland and the northern Western Australia, we don't have really high wind, no hurricane, no gale force wind. So we don't need to have the sheathing to support the structure. And because our climate is so mild, vapor barrier is usually not an absolute necessity down here as well. So it gives a lot of leeway for builder and designer to cut corners.
Yeah.
Yeah, what are the kind of common leakage rates that you see in the modern residential construction there with this building method?
Well, it varies a lot. Surprise, surprise. Even with some volume builders, before they put any additional effort to try to do airtightness, sometimes we can get permeability down to under 3 meter cube per hour per meter square, which is very, very good for a house. But the same builder with different trade team, it can blow up to 15. So it is not consistent, and it has a lot to do with the feature of the home. Usually, surprise to me, is the home that intend to build for rental actually perform better because it has minimal heating and cooling system, minimal number of light fitting. All those are cutting out the leakage point.
Oh, well.
There's less internal cavity sliders. There's no chance of having bulkhead concealed air conditioners sitting in leaky roofs and just a grill connected directly to a roof area. Usually the rich have really leaky homes down here, and the renting stock is usually, well, the new renting stock at least is quite airtight.
Yeah, that's interesting. Yeah.
The other interesting observation is for those homes that with minimal cabinetry actually perform better. The house built here, if they know you got a big cupboard on that wall, they don't even sheet that part of the wall with plasterboard. And it becomes a major leakage source.
Yeah. So plus is our airtightness down here.
Wow.
Isn't the greatest, but it is what it is, and yeah, it's vapor permeable, which is a bit of a problem. But again, we're blessed, like Joseph said, with very temperate weather in the majority of the country. Cool. Now, Sam, I believe you received a present from us.
I did. So I guess that's another thing to talk about efficiency matrix. You guys aren't just testing.
Yeah.
You guys also,
yeah.
you guys are coming up with products, solutions to issues, and software too. So talk a little bit about that side of it.
Yeah. So I guess, look, we're quite busy, but sometimes it's good to get our teeth into something a little bit different, and we've got some resources here that we can throw around on different things, which also helps in the training process as well. So the Q vent door vent, which we've developed, we wanted to produce something that was a little bit more than just a door vent, that had some sound attenuation properties in it as well, which would also give it a little bit more of a modern look and less of a commercial sort of feel.
Sure.
Because we need to engineer our houses for ventilation as well, which we think is absolutely incredible in the majority of building stock here in the residential space. Nothing is really engineered for airflows at all. From a ducted heating perspective, there's no consideration for return air paths, for exhaust. There's very little consideration for supply air paths, and we just thought there was a bit of a hole in the market of not many options to put in a door vent, which is less likely to impact the overall air tightness of the building as well when it's stuck in a door. As soon as you have to start thinking about putting in a wall vent, then in a lot of circumstances here in Australia, at least, you're putting a hole in the building envelope that's going to potentially leak as well.
Well, I just want to say it also brings back to the way how we call in to visit some of the existing building, and how we find that a lot of the system design for residential building, in particular in Australia, are based on the homes that has absolute no insulation back in the 70s when energy were cheap. They just crank in a high capacity gas ducted heating system to heat the home. And because the envelope were so leaky, any pressurized room, the air would just leak through the wall cavity and get to the outside. And then once they start to insulate those homes, moisture problems start because the warm heated air got pushed into the wall because they don't have a proper return air path to get back into the system. And that's how it pushed us to see the need for a more residential friendly air grill design instead of the traditional. I think John was very generous to use the term commercial. From my point of view, it's industrial looking, not even commercial. Yeah. People, when they see that, no way I would have that in my house.
Yeah. I thought you were just supposed to cut off a foot off the bottom of the door and you were good.
Yeah. Just get rid of the door altogether and just hang some beads. Yeah.
Until the undercut is so big, their pet cat can just walk through.
So I think the key word that you used earlier that of why this is necessary for homes that have ducted systems is a return air pathway. Because if you don't have that, then that's when things get really tricky in houses with ducted systems. Because then if you start closing doors, those doors kind of behave as dampers, right? And now that air that we're supplying to that room doesn't have a way to get back to that central return. And what I like about the product that you came out with is that it's just a simple solution. All you're doing is you're putting a hole in the door and then putting this grill over it that when you're finished, it kind of looks like it came that way. And it's giving that air a place to go. So you're not pushing and pulling on the envelope, making the house uncomfortable.
I mean, one of the other things that we see a lot down here as well is homeowners just pitching bathroom windows open for that supply air for exhausting as well. And then what they find pretty quickly then is that they start growing mold because the bathroom's so cold, especially during winter. So yeah, just having something engineered to just draw and potentially leverage off air leakage throughout the whole house rather than just a single bathroom and then you got that warmer air to get that air out before it starts condensing on even the duct that you're putting up in the roof to get it directly to the outside. The better off you're going to be. But we tried to make sure that with this design that it was obviously cheap to sort of manufacture, but also that it would have that foam attenuation in there, which none of the other louvered designs that you can buy on the market will have.
Yeah, and that's where the sound dampening aspect of it.
Yeah, and I think a lot of people sort of prefer some sort of sound dampening.
And the openings are offset from each other too, right? So you can't noise or something that can travel straight through there.
Yeah, so that foam is always lined up.
It is lined up to the opening on either side. So the way we've designed is that it sort of flips over to itself. So that's exactly lined up. And then when you put it upside down, it's obviously going to be at different heights in the door on either side, but it doesn't really matter because you're not looking at both sides of the door at the same time. And then, obviously you get that C-channel line up there. And it's just a screw fixing on either side. But we've been getting some great feedback, especially from you guys in the States. We've been getting quite a few sales, even though they have to wear the additional shipping costs. But hopefully they don't have to cop an additional tariff cost as well.
Well, 10%, extra 10%, unfortunately, from us. Yeah, lucky we make all these grills locally here in Australia, not something imported from China.
Yeah.
All the injection molded parts come out of Australia?
Yep.
Oh, that's great. Oh, that's awesome. A consideration for the open area and the vent when you were designing it, what did you have to think about there?
Well, we try to optimize the size of those openings to fit our building code. In our building code, we have a minimum ventilation requirement of 25 liters per second when the exhaust fan is running. So we try to optimize to provide a ventilation above that. That's in addition to the vent. We should still have a small gap undercut of the door. So we guarantee we have more than code required ventilation provided to the bathrooms.
So we predominantly have a requirement for bathrooms only. There's nothing for return air of ducted systems, although I know you guys do have a requirement in some states for return air paths, right?
In some scenarios, but by and large, it's not a requirement, and it usually becomes a pretty big issue because that's how most of our systems are in the States. We have usually one central return in a hallway or some part of the main body of the house, and then only supplies in the bedroom. Usually people see like individual returns to a bedroom as like a luxury add-on or something like that, but it's usually not necessary. And rarely do you see like transfer grills over the door unless it's might be meeting a standard for a affordable housing program or something like that. But no, I think this is a great idea.
Yeah, we're going to be also providing an option to use this in a wall as well.
Cool.
It's just going to be a snap-on additional couple of pieces that goes with it that allows you to sort of get a level of air tightness inside the wall cavity as well. And then it's perfectly shaped so that this will just slot inside that.
One of the reasons we choose the width of this unit to be 450 millimeter, which is roughly 18 inches.
And I think using it in a bathroom is something that, at least over here in the States, just isn't really talked about much, or why it would be needed. I mean, if you're running a bath fan and you have that door shut, now you're depressurizing that room pretty much. And if you don't have air, an opening for air to come from, then you're just pulling on that room. So you're pulling in outside air from maybe an attic or maybe wherever you have penetrations through a ceiling or a wall, to just really kind of work against what you're trying to do, to keep it cleared out. So you got to have a place for air to go, and you have to have a place for it to come from.
We've been doing some apartment testing down here, and we came across a project where the bathroom imploded from the exhaust system, actually.
Wow. Must have been some nice fans.
So they get better down here, actually, which is good and bad, I guess.
Well, one of the experience that we have here is the building and house design team. They never take the design as a whole system when they consider any changes. It's always piecemeal, one component at a time, but they overlook the interlink between different components. It's like when they increase the insulation, they don't think about what it leads to air leakage and potential mold issue and the need for ventilation. And when they change the ventilation system, they don't think about the makeup air path, how the pressure relief come across. It's one step at a time, but every time they hit a brick wall, if they got the feedback, they will think about how to improve it the next. But a lot of the time, they don't hear the feedback. And we just run into problems.
Yeah, there's a phrase we use over here called the house as a system, right? We have to think of a house as a system made up of components that have to work together, kind of like the human body, right? If you have an issue and you take a medication for it, it could have side effects someplace else. So you have to make sure that whatever you're doing to fix one thing isn't changing something over here. Yeah. So it all has to work together to get to where you want to go at the end.
If someone's interested in buying them, then they just visit your website. They're for sale off the website right now, or a different website, or? Yeah,
that's tighthouse.com.au that they're available right now. And that's where, we've been predominantly selling them. We've put it up for some awards down here in Australia as well. So we'll see how that goes. But yeah, predominantly the majority of the sales actually comes from YouTube and some of the installation videos that we've been making on that product and just showing off its sort of acoustic capabilities as well. It's pretty cool, and it's gotten off to a pretty good start. It's not huge yet, but we'll see how it goes with time.
Yeah, I'm excited to get mine installed, and my house is over 30 years old, and so right now we're going through redoing the attic insulation where we have to do whole house ventilation, and then right now the bath fans are removed, so I have to add new ones in because they were not ducted appropriately. They were just ducted into the attic. They didn't actually go to the outside. They just dumped, humid air where you didn't want it to go. So we're in the middle of reworking all of that. And then so I'm interested to see, once we have it set up like a normal house would be, see what those pressures look like whenever you run the bath fan with the door closed, and then add your vent in and see how much it gets relieved. So that'll be a fun video series to put together.
Absolutely.
Yeah. Well, we'll definitely put a link to it, to your product here in our YouTube description here. So whenever we get this posted.
Oh, yeah, most definitely.
So, yeah, the other thing that we've been working on as well, and that we use it prolifically on all of our inspections throughout the country here with all the projects that we've got, predominantly on our commercial and with some of our residential projects as well, is EIR, which is the Envelope Integrity Reporter, which we've been putting in a lot of effort in making it sort of like a machine gun type of defect or survey item logging tool. So where we can document a blower door test really simply and easily, documenting where leaks are on a floor plan where you don't need predominantly an internet connection to do that, but you just mark a location, take photos, quickly mark it up, and then it just captures all this into a little database on the actual handset. And then when you go to a good trusted internet connection, you can sort of just fire that all off to sort of sync up with a database in the cloud. We've got some really cool integration with FLIR's or Teledyne's thermal imaging cameras as well, where you can sort of line up a thermal image onto a good quality camera image from your mobile phone, and then mark up temperatures on the thermal image, and it sort of overlays those temperature points on the visual image, so you can see exactly where the temperatures are in a visual image, which is what everyone is sort of can sort of assimilate when it comes to thermography. It can be quite difficult to get an idea of what a thermal image is telling you, right?
Really, why that building is failing, right? I mean, the blower door number tells us, how leaky it is, but we don't really have much. I mean, we can use other tools to go through and figure out why, but until you guys came along with this, there wasn't really a recording tool designed specifically for airtightness testing to explain why a building is behaving the way that it is. So I think that's really cool. Most people will just try to make something on their own, like with SketchUp, or maybe pull some other kind of drawing tool, like maybe Bluebeam or something like that, and just try to tweak it to make it work. But I feel like that's something the industry has been needing. So what would that process look like? If you're going through a house, you've done your blower door test, say you're going through with a thermal camera or a smoke tool or something like that, how would you actually log where those problems are?
Basically we upload a floor plan into the cloud via the web interface for the actual project, and you can register the project as being usable offline, so that way you can sort of put the handset offline and just use it, no matter where you are within a property, especially in a basement. Potentially the internet connectivity can be problematic, and it really starts draining the battery when it's trying to ping the cloud. And then you just pick a location on the floor plan, take a few photos. You can mark them up before you go so that you know what you were sort of concerned with when you were there. And then you can leave all of the comments and stuff for back at the office, and you can sort of just really move through that, because what we find is we like to be able to be on site as quickly as possible and not sort of dwell there sort of dotting every I and crossing every T. We sort of just want to get all the main points, get as much data as we can that we need when we're there, and then sort of just do all the finer points when you get back into the office. But the other beautiful thing about our software as well is that even if you want to collect all of the information when you're on site, you can also fire off that report via the handset before you leave. And you don't have to sit there fighting with Word documents or Excel documents, just trying to line up where locations are of an issue, lining them up with photos so that you can actually get some really good outcomes from the trades that are having to find these issues later. The other thing that we're pushing for EIR to do, and we've built it into it, is giving the ability for just a tradie to connect to that project as well and just fire off remediation photos of each defect so that you can close them all out and then produce a report at the end of everything that was logged and how everything was remediated as well.
That's really cool.
Yeah, it's awesome. Like if you're working with a team and then another team member comes to the site, they don't have to have some full lowdown from everyone else who's visited there to understand what's going on.
Yeah, and you can easily zoom in on the floor plan on all the defects that are there and basically, see at this point what was the issue, and then you can fire off that remediation photo too. But the other really cool thing from your perspective is that how easy it is to also log where you put a reference tube, where you put the blower door setup, what the blower door setup was, the serial numbers on the fan and the manometer that was used. You can even go back and sort of really start to verify and double check everything that was done at a job, which for us, all of the guys that we're going out to do airtightness testing now, we get them to log the fan setup, the serial numbers of everything that was used, so that we can cross-check the reports that we're firing out as well.
Cool. So you're not just using it to map out problems, you're actually using it to prove what you did when you actually did the test too. So you're kind of killing two birds with one stone there.
Absolutely. It's just so quick and easy. So why not?
And is like that available on the App Store now for everybody? Or like, I know you designed it for yourself.
It's available to download, but at the end of this month, we'll be offering up subscriptions.
Okay.
To
start using it. We have imperialized it, so it should be useful for you guys.
And so really all you need is the building floor plan to upload into the app, and then you go from there.
But how do you scan the building plans, or you take a photo of them or something to put it into how do you get it into the app?
You could take a photo. I mean, all you really need is just to give an idea of locations. But yeah, usually we just upload PDFs of the floor plans.
So you just have a big scanner at your office that you scan them in and then generate the PDFs?
Well, usually we just get sent the PDFs and then we just throw them straight in.
Yeah, if we go to existing building, they got whatever plan from the council or from the previous owner. In those cases, we just take a photo.
Yeah, and I think the plan is eventually there are some of those apps for
like Cubicasa or things like that.
Yeah.
We're planning on integrating something similar to that into the app as well.
Yeah, I was trying to think about, if you're in an existing building and maybe you don't have plans, there's a couple of software companies now that a lot of our HVAC companies in the US are starting to use that LiDAR technology to scan, whether it's Cubicasa or another. One of them is called Conduit, where they actually go through and scan, and then they can create the plan, and then they can do their load calculation from there. So once you have that, now you have a plan.
Yep.
So then you can take that drawing and then apply it to your app.
Correct. So shortly, the other thing that we're going to be doing is using the LiDAR cameras on these, especially the iPhones, with the thermal imaging. With an anomaly, we'll be able to get a surface area to put up against that a thermal anomaly of potentially problematic insulation, to then start outputting a percentage of insulation uncoverage.
Wow.
For a building. So potentially we're aiming to turn this into a blower door test for thermal insulation consistency auditing as well.
Wow, man, that'd be fantastic, yeah.
So actually, I probably didn't mention. So our software, EIR, it's got a website already. It's envelopeir.com. So subscriptions will be available from that website towards the end of this month. So we might beat you guys.
Well, I think probably when this episode airs, it'll already be available. So if you're listening to this, now you can go and subscribe to the software and go ahead and try it out.
The end of month means the end of April 2025. The end of month means the end of April 2025.
I was going to say, isn't Atma moving into Australia?
Yeah, look, and this is probably a question that we'd like to fire off at you guys as well. I mean, predominantly in the UK with ATMA, I think a lot of the tests are still done quite manually. They're not done automatically. What are you guys finding in the States? Are the majority of tests done manually with like a Fantastic, or are they just putting in manual sort of pressure points inside Fantastic and reporting like that?
If it's a commercial test, it's almost always done with Fantastic or TechLog, whatever the brand is that they're using. It's usually just easier to run the test that way. I feel like we almost never see a manual test in that scenario. But when we get into residential, it's a different story. We still run into the problem of testers just pencil whipping projects, because in a lot of those cases, they're getting paid by the builder, who has to meet a code or an above code program, whatever it is, or if they're trying to get funding or whatever. And so if the tester isn't giving them what they want, they'll fire them and go get a tester that will. And so I feel like it's getting better in that regard, but it's still an issue as far as verifying tests, so they actually happened or were done correctly. Yeah, but in commercial, we don't really see that problem much. I mean, those are the software just makes it easier, so you're going to do it right. And it's a lot easier to go back and catch things that weren't done right. But in residential, it is still a problem. It's funny, we're really trying to achieve the same goal in both residential and commercial. It's just two totally different industries that are doing it. They don't really communicate with each other. Yeah.
That's why we kind of promote the use of our cloud, so it has like the geolocation capability and the timestamps, and then the validity of the data and the reporting. And if somebody actually went and manually changed any of it, then it shows up on the report as kind of highlighted that it's a manual entry and stuff like that. So it makes it a little bit more challenging for someone to fudge the numbers on a test and stuff like that. But as Sam mentions, you still find people just want to get in and out. They don't want to have the hassle of the software, perhaps, and so they just jot down whatever number they saw on the gauge or take a photo of it or whatnot, and then But
and that's what a lot of the ones that are actually enforcing these tests, that's what they're still requiring. Like, make sure you take a photo of the manometer, which to me is kind of silly. You could take a photo of any manometer anywhere and, provide whatever number that you want. But unless you have an actual report that's generated from the manufacturer, that's really how you're going to get it right.
What you need is a photo of the fan range and the manometer, right?
Yeah. But I don't think most testers understand that they can do that. So, I mean, if you're not smart enough to actually understand that it's faster just to go in and test it and call it a day, then I don't think they understand the inner workings of what they're actually doing to that much detail. So
cat's out the bag now, though. All right, awesome. Well, enjoy, guys. Enjoy the rest of your day. Enjoy Easter. Appreciate you.
Yeah.
Thanks. Now.
Appreciate you guys coming in.